All right, so we're going to be talking about section 1.1 in this video, so you can follow along with your handout that's in your week 1 materials. And the subject is linear equations. Now for chapter 1, in general, the topic is solving equations and inequalities. So we're going to be going through all kinds of equations, but the main two categories that you see in this algebra class will be linear equations and quadratic equations. Linear equations, you can tell they're linear when x is raised to the first power. You don't even see an exponent, so it's understood to be the first power. So first degree equations are considered linear equations. Just to let you know, in a later section, we're going to look at quadratic equations. Quadratic equations means there's a second degree power somewhere in the problem. X is raised, or your variable is raised to the second power. Second degree equations are called quadratics. Now there are third degree, fourth degree, on and on, but this is the main two things that you see for most of your problems. And also know that however many degrees, like first degree, you're looking for one solution. If it's second degree, you're looking for two solutions. If it's third degree, three solutions, and so on and so forth. And as noted here, the degree, third bullet point down, the degree of the equation tells you how many solutions you're looking for. All right, so today's lesson, 1.1, we're going to be looking for one solution, a linear equation. All right, so I have an example for you to follow along with. Notice that we have x to the first power. It's understood to be x to the first, making it linear. The first thing that I would do to solve this equation is distribute and make that 6x, and there is an understood times there. So 3 times 2, 6x, 3 times negative 4 minus 12. On this other side, the 7 is not to be distributed. The 7 is an independent term, so it's brought down. What's to be distributed is the negative 1. There's a negative sign in front of the parentheses. It's an understood negative 1, so we distribute that. Negative 1 times x, negative 1x, negative 1 times 5, negative 5. And so after you distribute, you should simplify each side as much as possible. If there's any like terms, like on this side, there is not, so we just bring that down. On the right side, this positive 7, and you always look in front of it for the sign, positive 7 and negative 5 will reduce to a positive 2, then bring down the minus 1x. So you've simplified each side down as much as you can, then you're ready to move your variables to one side and your numbers to the other side. So it doesn't matter which side, but I'm going to take this over to the left side, this minus 1x, to make it appear on the other side. You're basically changing its sign. Negative 1x and a plus 1x would cancel each other out. So you're adding 1x to keep the balance on the other side. But the shortcut to that you probably know at this point is you just throw the term across the line and it changes its sign. So negative 1x becomes positive 1x when thrown across. And then combining it with the 6 for a total of 7x. Now for the numbers or the constants, you want to take those to the other side. So bring the minus 12 over, makes it plus 12. 2 and 12 is 14. Bring down your equal sign. And then the last step in solving linear equations is to divide by what's with your variable. This x is understood to be multiplied by the 7. So the opposite of multiply, we don't want the whole term to go, by the way. We just want the 7 to reduce. We want to keep the x. So it's not like we want to move the whole term. We just want to get rid of the 7. So dividing by 7 makes that times 7 divided by 7 cancel out to be a 1x. We're always looking for x in algebra, you know, so finding your x or 1x equals, do the same thing to this side, divide by 7. 14 divided by 7 is 2, for a final answer of x is 2. We should always check our answers. I'm kind of lazy about doing that, to be honest, but it's a good idea to check it back in the original problem. If it truly is the right answer, it should solve and make the two sides equivalent. So you could run that through your calculator, or by hand. That'd be 2 times 2 is 4. 4 minus 4 is 0. 3 times 0, that side's just 0. So the other side hopefully is 2. This side is 2 and 5 is 7. 7 minus 7, that side's also 0. It's not always 0. They just have to be the same thing on each side. So it just happened to be 0 this time. So it works. It checked out. So the steps to solve any linear equation is number 1, Number one, we should get rid of any fractions or decimals. That's always a first step. We didn't have to do that here, but if you want to jot down the steps, step number one is clear fractions and decimals. We're going to see some examples with fractions and decimals here in just a minute. Fractions or any decimals. We do that by multiplying through by the LCD. If it's a fraction, you want the least common denominator, the least common multiple. You multiply it to each side, and that distributes and takes care of all the fractions. It makes it easier to work after that. And we use kind of that same strategy with decimals. If there's decimals that are to the 10th place, we multiply both sides by 10, and it will reduce all the decimals out. So you always want to clear your fractions and decimals. Then the next step is use your distributive property, like we saw in the last example. Then you want to simplify each side as much as possible. That's sort of what you're doing when you distribute too, but you want to continue to simplify each side, separately on the left and the right. Combine any like terms on the left, combining the like terms on the right. Get it simplified as much as you can on each side. At most, after you do that, you should have at most two terms, maybe a variable and a constant on the left and the same on the right. So at most, you'd have four things at that point. Then you're ready to move your variables to one side and your constants to the other. You need to pick a side for your variables and move everything to that side. So move your variables to one side and constants to the other. Just your number terms are your constants to other. Once you do that and you've simplified using your add and subtract rules for those, the last step is divide by what's with the variable. And then really the last step should be check that answer. Make sure it works in the original problem. All right, and those are pretty much the steps to follow for all these problems we're going to be looking at on the next page. Now, sometimes when you follow these steps, you get a situation where your variables disappear. Maybe the x's were the same on each side. Say you had x plus 3 equals x plus 4, for example. That is a linear equation, but we're not going to be able to get a solution from it. So there's special situations that will occur in any type of equation solving. There's just no answer for this. There's no number when you add 3 to it that is equivalent to that same number adding 4 to it. That just doesn't make sense. But if we were to use our steps and bring the x's together, this x crossing over, the x's drop out, and there's not an x left at all, not one x, no x's, okay? You just have these constants, 3 equals 4. And that just doesn't make any sense. You might know something's up with that. It just wasn't solvable. That is no solution. And that's what is at the top of this next page. There's 3 types of equations or situations you can run into when you're solving these equations. Number one is if you're solving a linear equation and it leads to a true statement, if it would have been 4 equals 4, or 0 equals 0. If it would have been a true statement, the equation is an identity, and so just everything works for it. Anything you plug in, the two sides are mirror images of each other. Again, we call that an identity, and the answer would be all real numbers. Second scenario is what we did on example 1, is if you get an answer like x equals 3 or x equals 7 or x equals a constant, it's called a conditional equation, and it's going to work with the condition that x equals that number. So it's called conditional. Those are your normal equations where you get an answer, the one answer you expect in linear. And then the third situation is if you're solving a linear equation and it leads to a false statement like we just saw here, because the variables dropped out and it's just not solvable, there's no solution. The empty set, that symbol means no solution, and we call that a contradiction. So when we do these examples, we're going to go through, that's what we're going to see, some of each of these. So just wanted to go ahead and get that out there. Contradictions, what that's called when there's no solution. Okay, now we're going to do some practice problems and go through those steps in various situations. I really do believe practice makes perfect with these, just seeing different equations and practicing different scenarios. So what I want you to do, if you were in class and doing this in person, I would have you work number 1, then I would watch you work that, I'd make sure you got the right answer, and then I would go through the steps. So that's what I hope you do on the video too. So after I write this problem on the board, pause the video, work that on your own, and then I'll go through the steps. And that's more active learning for you. If you're actively working this, it just connects better with your mind. So I encourage you to do that with any of the videos that we go over to participate that way. All right, so hopefully you pause the video, and now here we're gonna work it. Step number 1, I will distributing the negative sign on the other side. So nothing reduces on the left side, so I just bring down those 2 terms, whereas on the right side, a positive 3 and a minus 7 should combine to be negative 4, and then minus 8x, and those can be in either order. Then I'm ready to move things across that line. So either direction, I want to bring this minus 12x to the right. I kind of have a habit of trying to get my variable to be positive if I can, although it's not a rule, but it's just something I do. It can go either direction. So minus 12 brought across makes plus 12, negative 8x, and positive 12 is 4x. Using our subtraction rules or addition rules here, negative 8 plus 12 is 4. Bring this minus 4, the constant, to the other side, makes it plus 4. 20 and 4 is 24. Last step is divide by what's on your variable, so we'll divide that by 4 on each side for a solution of 24 divided by 4, which is 6. Then that is a conditional equation, right? We call that a conditional. And when you're doing your homework, it'll ask you these little words. So what type of equation is it? Conditional. It is true with the condition met that x is 6. And we should check it. If we put in 6's for these x's, we should be able to confirm that the 2 sides are equivalent. Okay, doing that again on number 2. Again, I encourage you to pause the video, work number 2. So going through the steps here, we'll distribute. Negative times a negative is positive. Also kind of reviewing some of these rules. I know you all have calculators, but it's also good for you to also know these rules. It will help you, believe it or not, even things you know how to do on your calculator, just kind of innately knowing your rules, it will help you be a better algebra student. So I'm kind of trying to remind you of those 2 as we're going through these. So negative times negative, we're multiplying, so that's positive. Then negative 5 times positive 5. On the other side, the 7 is a constant, bring it down, but then the negative sign is what's being distributed. So making negative 4x and minus 7. Then you're going to simplify each side down. The left side does not reduce. The right side, the 7 and minus 7 would cancel out. We would just have this minus 4x. Then I'm going to move my variables to the same side. So I'm going to pick the left side here, this minus 4x, bring it across, makes it plus 4x or 14x altogether. Minus 25 needs to go to the opposite side. There's no other constant, so it's just that 25. Last step, divide by 14 on each side. And I would leave the answer right like that. That is the most exact answer and the way that you'd plug it into your MyLabs program. All right, the next example, we're going to see one that has fractions in it. So we'll be practicing the clear the fraction step to start that one. So number 3. I'll demonstrate this one for you, and then maybe the next one would be good to pause the video and try solo if you've not seen this method before. So again, we times through by the LCD. So you look at all your fractions, and the LCD of that is going to be 12. 12 is the least thing. All those fractions will go into evenly. So I'm multiplying both sides by 12. And then by doing so, when you multiply, it cancels diagonally. So you're multiplying 12 or 12 over 1 times a fraction. They're really diagonal. So this cancels into that 4 times, and then 4 gets distributed here onto that term. Now, we do have to distribute the 12 onto both terms, so 12 is then distributed here 12 times a half will be 6x. And then we're distributing the 12 over here for a 3x, and 12 times that is 28. And then we'd proceed from there. Okay, I'm gonna pause the video and come back.